Hi class, we finally made it to chapter 8 on water treatment. We'll be combining the other knowledge from previous chapters like biology, what's in your water. We've learned about viruses and pathogens, and we even started one of our first lecture with looking over consumer confidence reports. So from your glossary, hopefully you remember the purpose of water treatment, and that's to provide potable water that's also palatable. So, I mean, you want the water to be safe for drinking and not make you sick, but it's also important to ensure that it's palatable. So taste, odor, color is also important. I wouldn't really want to be drinking this if it was brown, even if it's not going to make me sick, or if it's a little salty, that's not going to really impact my health, but people aren't going to drink it. Or if there's like a lot of water that has, iron in it, might be a little brown, it's not harmful. So then people won't drink it and they'll go to bottled water, which is not sustainable. So this lecture is meant to be watched for Tuesday, April 21st on water treatment. So we are on chapter 8, and we'll be doing it in one lecture, so just hitting on the highlights. This is an introductory video, so for the introduction, the objectives I'd like you to come away with are to understand the importance and purpose of water treatment, awareness of the United Nations Sustainable Development Goal 6 and how it is related to water treatment, and describe the Safe Drinking Water Act in the United States and what it does to ensure clean drinking water. So as I said from the little intro, purpose of water is to provide potable water that is palatable. So breaking that down, potable water is healthy for human consumption, free of harmful microorganisms and organic and inorganic compounds, chemicals, pollutants. Palatable water, as I said, is aesthetically acceptable to drink, so free from turbidity, color, odor, and objectionable taste. So, as I said before, water that is not palatable may be safe, but also water that is palatable may not be safe to drink. So I don't think you'd want to go around and drink from the canals on campus, even if they were clean, or from a puddle. It might taste okay, probably not, and it's probably not very safe for you. And as I said, even though water might look a little funky, it might be, safe to drink, but it's, not necessarily what you want to drink. So these are good examples of true-false questions you might have on quizzes or exams. So be ready to know the distinction between the two. So most of us are pretty fortunate. We open the tap, we get clean drinking water. That is not true for a lot of people around the world or even in the United States. So the United Nations has made the 17 Sustainable Development Goals to achieve by 2030, and one of them is to ensure availability and sustainable management of water and sanitation for all. We'll get more into SDG 6 for wastewater treatment in the next chapter, but 785 million people remain without even basic drinking water. So it's a population of 7 billion, that's nearly 1 billion, nearly 1/7 of the world's population. And a lot of people lack access to basic hand washing facilities, soap and water. That's especially relevant today with the COVID-19 pandemic. So as I said, clean drinking water isn't just an issue in developing countries in Africa and Latin America or Asia. India is a major hotspot, but also in the United States, also in the Central Valley. There's estimates of anywhere from 1 to 2 million people in California lack access to clean drinking water. We've seen the issues with the Flint water crisis. So there are still some pockets. The United States has over 90%, access to clean drinking water, which is much higher than other countries, but there's still a lot of people that lack access to clean drinking water, especially vulnerable populations, Native Americans, homeless, and we do have legislation. We talked about the Clean Water Act before to protect water in general, but there is the Safe Drinking Water Act. I have uploaded or given you links to videos by Dr. Belinda Strum She has 2 videos on the Safe Drinking Water Act that goes more in depth if you're more interested. So things used to be a lot worse. I mean, in the world in general and in the U.S. So I do talk about a lot of these statistics, and they are bad, but we've made a lot of progress. And so the United States had very deficient systems up through the 1970s, outbreaks of disease, and carcinogens were in the drinking water. It was a pretty bad situation, and so this bill was passed in 1974. And so here are some of the major provisions for the Safe Drinking Water Act. So they had primary and secondary standards, and public notification requirements, and funds for research and state programs. There's been a lot of amendments of the Safe Drinking Water Act. We won't get into all of them. And so in the 1980s, there was provisions to improve, require disinfection for drinking water treatment, which we'll get into when we talk more about the water treatment process. One amendment that's evident that we've seen from the beginning of this class is the consumer confidence reports that are required for every drinking water utility, and the maximum contaminant levels. So MCLs, remember those, and maximum contaminant level goals. And so look at the text here that MCLs maximize health risk reduction benefits at a cost justified by the benefits. So we could remove everything from the water, but that'd be very, very expensive. So we use calculations from Chapter 6, Environmental Risk, to develop these standards. And so there's a lot of things in your drinking water. We'll get more into these. Your table 8.2 kind of summarizes the different categories. So you have inorganic constituents, calcium, sodium, fluoride, not just the fluoride we add to drinking water for protecting your teeth, but there's naturally occurring fluoride, which actually at high concentrations can be really bad. We all know about nitrates that can cause methylglomania, which is blue baby syndrome, or other health effects, iron, manganese. There's inorganic constituents, so there's heavy metals, there's lead, mercury, chromium-6, arsenic. These have a lot of very detrimental effects to human health and cause neurological disorders. We have our naturally occurring organic matter, synthetic organic chemicals, kind of pollutants from industry, benzene. Remember that was one we covered in environmental risk. So these from industry, households, or agriculture. TCE is a major one. I know people in this class have mentioned it was an issue in the Bay Area, in their schools, and their drinking water. And then, of course, living organisms, bacteria, algae, and viruses. So there's a lot of research going on, especially with the current pandemic, about its survival in wastewater and water. So don't be too concerned. The disinfection processes and things we use have been very good at eliminating the virus. And so it's not resilient to disinfection, so it usually gets destroyed. And from Chapter 7, as we learned of the different types of water, surface water, groundwater, seawater, and even reclaimed and reused water. So there's lots of places we can get water and treat it, and they all come with their pros and cons. So surface water might be easier to get if you're near a river or a lake, or you've made a reservoir, but they can have a lot of highly suspended solids, turbidity, pathogens, things just wash into surface water pretty easily. So groundwater might be cleaner, but also it depends where you are. It might be more protected since it has the soil layers and natural filtration. But there can be naturally occurring geological formations, such as with arsenic, with fluoride. So that water, just by nature of what's in the rocks around it, can be pretty bad, as well as contaminants that people have either injected or has filtered through from agriculture. Seawater, I mean, it has a lot of salt, so desalination is really expensive, but it's becoming cheaper. It uses a lot of energy. Reclaimed and reused water, similarly to seawater, just takes a lot of treatment to get there, but it's an important source. And so these kind of other sources like seawater and reclaimed and reused water are definitely becoming more important as water scarcity increases, as we learned from Chapter 7. And it's good to have a wide water portfolio, not just relying on one source in case something happens, like a drought happens, or you're not able to access the water. So you need, multiple sources. So a lot of coastal areas are putting in desalination plants, even though they're more expensive, to have more of a diverse water portfolio. So hopefully you've been able to understand, the importance and purpose of water treatment, learned about SDG 6 and the Safe Drinking Water Act through this video. Of course, let me know any questions you may have, and see you on Zoom. Thank you.